Pythagoras problem that's been completed incorrectly. Can you spot the error? So let's see where the error was. So the x is the hypotenuse. It's opposite the right angle. It's the longest side of the right angle triangle. So we were doing an addition. So we're going to square the other two sides and add them together and then do a square root. So yeah, we've got 6 squared plus 9 squared, but the error is the 12 here, because 6 squared is not 12. 6 times 2 is 12, but 6 squared means 6 times 6, which is 36. And then we could have added those together to get a new sum of the square, and then square root. Have a go at this one. There's also an error in this problem. So the solution for this one is 16.1. Now if I have a look at my triangle, the longest length of the right angle triangle is opposite the right angle, so it's here, and it's really important to mark the longest side with a H so you know it's the longest. So how can the other side then be 16.1? Because this should be one of the shorter sides. So what's happened here is that the person's done an addition instead of a subtraction, so it should be the longer side, 14 squared minus 8 squared. So that should be a minus, and then once you've done your subtraction you can square root. Now Pythagoras can only be used on right angle triangles, but you might need to extract right angle triangles from other types of shapes and triangles. So for this one, find the height of the triangle. So we're looking for the height of the triangle. I can call that H. But this is an isosceles triangle. I know it's an isosceles triangle because 2 of the lengths are equal. And what I can do is split it in half and use one of the triangles, because it makes 2 right angle triangles. So there's another one on this side, but I only need to use one of the right angle triangles to find the height. So if you want to, you could redraw a sketch of the triangle, the new one. So we want half of 8, so this length at the bottom is going to be 4 centimetres. We've got that diagonal, which is 7, and we're looking for the height, which we can call x. So because we're looking for a shorter side, we've got the hypotenuse. We can do a subtraction, so I'm going to do a subtraction. So x squared is going to be equal to the longer side, 7 squared minus 4 squared. I'm going to type that into my calculator. It's 33. Then I'm going to do the square root of 33. And I'm going to round that to 1 decimal place so the 4 doesn't do anything to the 7. So that's 5.7 centimetres. So the height of this isosceles triangle here is 5.7 centimetres.